Today we're going to have a look at simultaneous equations. Now, simultaneous equations are where we have two equations and two unknowns, usually an x and a y, but it can be any letters at all. They're called simultaneous equations because they need to be solved at the same time, i.e. simultaneously. They can be solved in three different ways. They can be solved graphically, by sketching the lines and finding the point where the two lines meet, by algebra, by either elimination or substitution. The way we'll concentrate on the most is doing it by elimination. I'll show you graphically, I'll show you substitution, but it's really elimination that you'll use. Okay. First way then, graphically. I'm going to draw the lines here. You don't need to worry so much about the drawing of the lines. It is more about being able to solve them once you've got the lines drawn. Okay. So my first one here, I've got the line y equals 2x minus 4. If I compare that to y equals mx plus c, that means it cuts at minus 4, so it starts down here at minus 4. I've got a gradient of 2, that means every time I go along 1, I go up 2. Oh. So I go from this box here, I go along 1, up 2. Get rid of that. Along 1, up 2, along 1, up 2, along 1, up 2, along 1. 2, and that gives me my first line. Let's see if I can remember how to turn this now. Okay, line up my ruler, and that is my first line. Oh no, now I've got two rulers. So that's the line y equals 2x minus 4. The next line, I've got y equals, I'm just going to write this round the other way, y equals minus x plus 5. Let's pick another colour. That means it crosses at 5. So I'm starting here at 5. It's got a gradient of minus 1, so every time I go along 1, I go down 1, long 1, down 1, long 1. Down 1, along 1, down 1, and so on. Let's see if my ruler is going to cooperate this time. That's not too bad, that'll do. Draw my line in here. So that's the line y equals minus x plus 5. And what I'm interested in is the point where these two meet. Now, it should be right on that point there. It's just been my bad drawing on this. You can see this line here is not quite in the correct place. So your point of intersection here would be the point 3, 2. Remember, we always go along first, so along to 3, up to 2. So a point of intersection to this ruler is the point 3, 2. That means the solution of this would be x equals 3, y equals 2, because the x coordinate is 3, the y coordinate is 2. So that's us found two solutions. Found one for the x, one for the y, but it's one whole solution that fits both equations. Okay, let's try another one. First one, I've got 3x plus 2y equals 12. So 2y is minus 3x plus 12. So y is minus 3 over 2x plus 6. Don't worry too much about this part. I'm not overly interested in you drawing these lines. Comparing that to y equals mx plus c, that means I'm starting here at 6. I've got a gradient of minus 3 over 2. So that means every time I go 2 horizontally, I go down 3. So I've got along 2, down 3, along 2, down 3, along 2, down 3. Let's try the ruler again. There we go, that's not too bad. It's not 100% accurate, but we're close enough to find out where a point of intersection is supposed to be. The next one, I've got x minus y equals 4. So that gives me y equals x minus 4 rearranging. Compare that to y equals mx plus c. I start here at minus 4. Got a gradient of 1, so go along 1 up 1, along 1 up 1, and so on. You can see there where my point of intersection is going to be. Oh, I've got to go along 1. Okay, that's close enough. So there's my line x minus y equals 4, and here is my point of intersection. So my point of intersection is the point 4, 0. Okay, the only part I'm interested in you being able to do is read out where these two meet. So don't worry about the drawings of the lines, not interested in that part. All we need to do is when we find our solution, when we have simultaneous equations, start again. All we need to know from this part is if we are solving simultaneous equations graphically, it's the points where the two lines meet. Okay, I'll leave you to try some.